Thank you all. Thank you for spending this time with me, and thanks for coming. I hope you're all having a great time. Smile, people. You all look very sad, as if you have been forced into this room. Yeah? I hope that's not the case, right? Cool. Anyway, so welcome to my talk. I'm going to talk about a passwordless future. So I'm DEEPU. I co-lead, co-chair the JHipster project. Java champion, yada, 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 open source person, developer advocate, polyglot dev, all that stuff. You can find me on socials. Yeah, quite outdated book, probably. I don't think you need to buy this book. It's too outdated now. So let's start. Why passwordless, right? Why do we need to go passwordless? We have been having a pretty great time with passwords, right? It has been around for like 1,000 years. We are happy sharing our Netflix passwords. So convenient, right? So why do we need to get rid of that? Verizon publishes like a yearly survey called, like a report called Data Breach Investigation Report. And the last one, 2023, according to that, 65% of all breaches has something to do with credentials. So phishing, social engineering the credentials out of people, credential sniffing, all this. So password related, right? 65%. And in 2022, that was 70%. So yeah, 5% have come down 5%, but still, that's a huge chunk of breaches that has something to do with passwords, right? So it would be really nice if you can get rid of that category altogether. Get rid of passwords. We get rid of those 65% of issues, right? So bury your issues, right? But passwords inherently are not problematic. I believe it's us, always the weak link. Our species is not evolved to, handle something like passwords, right? Because, you have to memorize them, you have to keep them complex at the same time. That is like kind of not possible, right? If it is too complex, they're hard to remember. If it is too simple, then, someone can figure it out. So we are not made to use password properly, and we have shown that a gazillion times, and still people trust us with passwords and stuff. So let's discuss this a bit more. Why, apart from the generic stuff, why it is actually problematic, right? So passwords are knowledge base, right? So it's something you remember, or it's something you know. And as I mentioned, if they're easy to remember, easy to hack into as well, and if you make them too complex, hard to remember, then what happens? You end up reusing passwords. Also, they are easy to share around. They are easy to get hold of. And most importantly, people can be very easily socially engineered, right? Social engineering is not that difficult. You call like a support center or someone. You play an audio of a child crying or something. You sound very dramatic, as if you are trying to I don't know, do something with the baby, and you're trying to reset your passwords. You do these kind of emotional manipulations, and you can kind of a lot of times you can get that person to reset the password or something like that. And you can find numerous videos on YouTube of people trying these kind of things, right? So it's not that difficult. I think there was a 14-year-old boy in London who was involved in like a really big breach, and the boy apparently did social engineering. And when you read these postmortem reports of major data breaches and stuff, they're pretty. Some of them are pretty extensive in terms of how much they trace, how much information you can find in the report, right? You'll see that the steps that these hackers, the so-called sophisticated hackers, take are pretty simple. Most of the time, they're just Google searching how to do this, and they're just executing it in the proper steps, and then going after people's vulnerabilities, right? So again, us problem, right? And another issue with passwords, it being passwords, is phishing, right? Phishing only works because passwords are passwords. I'll get into more there, right? I think even the most tech savvy among us sometimes, right, can get phished. It's I think there was a reason I forgot this guy. This Linus Tech Tips is a popular YouTuber. He talks about security and stuff, and he got phished because it was apparently middle of the night or something. You wake up from your deep sleep. You are like you're not smart anymore, right? You're like a child when you wake up from a deep sleep. So yeah, it's not hard to fish credentials out of people. And another issue with, again, passwords being password is that someone can break into your accounts remotely, right? Someone can sit in another continent, access your accounts, and you wouldn't even know unless you have some sort of 2FA or something set up, right? And again, all this you need to think from the perspective of the majority. Majority is not tech people, right? Majority of people using passwords are common folks. They don't know much about tech. They don't know. They probably don't know beyond the Google Chrome's inbuilt password manager. They don't know about 2FA. Most of them wouldn't set up multi-factor authentication unless it is forced upon them, right? How many of you are your parents' password managers? I'm my parents' password manager, right? So it's for non-tech people, it's even worse, right? Passwords are even worse. And if you don't have secondary security mechanisms like 2FA, someone will access your account, then you will only know when something bad happens and you're, oh, I got hacked, right? Another issue with password, again, on the server side, when we store passwords, data breaches, right? So data breaches happens because we are storing sensitive information. So if passwords are the only sensitive information on your server side, then your servers are attractive to hackers because you have passwords, right? And when you get a database of passwords, there's a huge market for password databases in the dark web, right? You can sell password databases. So data breach, again, because of passwords, right? Another issue with passwords, it is reusable, shareable. How many of you reuse passwords? The same password for more than one service? I do. I can't remember more than like 3 complex passwords. That's my memory capacity for complex passwords. So if it is like a non-critical service, and if I of course I use a password manager. So there's only like few instances where I cannot use a password manager. There are certain services which makes it extremely difficult to use a password manager. Those are like really evil services. They think it is security, but it is like anti-pattern of security. But there are some that do. And of course, sharing, right? Great for Netflix and stuff. Of course, doesn't work anymore, but not great for security. And another issue, again, on the server side for us tech folks, password management. Because it is sensitive information, we have to do more than just save passwords, right? We have to solve them, we have to encrypt them, we have to build recovery flows, we have to build reset flows, we have to build multi-factor authentication flows, so on and so on. And like in enterprises, you might want to implement password rotation policies and stuff. So there is a lot that you need to do around passwords, right, to make them secure just because we are using passwords. And there's a number going around that a password reset apparently costs anywhere between $70 to $100 in terms of the human effort and all that cost that goes into building those things. So, of course, the obvious solution would be to go passwordless, right? Get rid of passwords, we solve all the issues. Well, it's not that easy. We already have some sort of passwordless things. We have biometrics, which is kind of pseudo passwordless, at least after the first time you enter your password, then for a while it is kind of passwordless. And there are some services where you can actually use biometric as passwordless, even as first factor. We have magic links. We have services which doesn't ask you to set a password. Instead, every time they'll send you email with a link that you need to click. Open Collective does this. Nice, but not very convenient. The user experience is affected. You have to go into email and stuff, right? Similarly, OTPs. Some services, they will send you a one-time password over SMS. Again, not very secure because snooping SIM card is not that difficult. So again, not secure. And push notification. Google does this. If you set up Google as your SSO for services, sometimes you can set up in such a way that it will give you a notification where you have to accept in order to log in, right? So that's also kind of passwordless. But none of these are very ideal solution. None of these get rid of all the issues that we saw. None of them are safe enough. So that is where passkeys come into the picture, right? So passkey is a unique cryptographic key pair which you can use to identify yourself on a web service or a web application. So you can use it as your identity, right? So, and in my opinion, passkeys are the passwordless future that we all want. It's secure. I'll go into details of that. So before we dive into passkeys, I think we need to understand some basics on how this works and what makes it possible. Some of this might be familiar to you, but bear with me. So first thing, what makes passkeys possible is asymmetric public key cryptography, which is nothing but a pair of mathematically linked keys. which you can which you can prove that they are a pair, they are a unique pair. So you can use public key cryptography for two purposes, right? You can use it for encryption. So if you have someone's public key, you can encrypt data with that, and you can share it or whatever. And then only the person who has the private key can decrypt the data. And the nature of public key cryptography is that the public key, as the name suggests, is public. You can share it freely. And the private key is, of course, secret, which you need to keep secure, right? So you can use them for encryption. Another use case is signatures, right? This is how PDF signatures and all those digital signatures work, right? So you have a private key. You can sign some whatever data using your private key, and whoever has your public key can verify that this particular data has been signed by this person, because you have this person's public key. So only the private key corresponding to that public key could have signed this document. And that is why digital signatures are accepted as valid forms of signature, and they're much more safer than actual signatures, right? Because hard to forge unless you have the person's private key, right? And this is the mechanism that Passkeys make use of as well. So it uses the digital signature process, because this process is nothing but proving identity, right? So you can actually use this the same way you use passwords to prove identity. So another important piece of the puzzle or technology is authenticators, right? An authenticator is a hardware or software device which can create and store private public key pairs. So this device or software should be able to create asymmetric public keys and should be able to store self-contained. It shouldn't just create and send it to someone else, or like some other service or some other storage mechanism. It should be able to create and store those self-contained. So that's authenticator. And there are two types of authenticators. We have platform authenticators. So platform authenticators are built into devices, like Touch ID. Technically, Apple's, I think they call it Apple Enclave. It's a platform authenticator. Face ID, I think similar. Apple Enclave platform authenticator. The authenticators in your smartphone, they are platform authenticators. Windows Hello, platform authenticator. So anything that is built into a device, a mobile phone or laptop, you shouldn't be able to remove that authenticator. Then it's a platform authenticator. And another type is roaming authenticators. Again, as the name suggests, these are devices that are removable, and they are either connected using USB, NFC, and sometimes combination of one of this and Bluetooth. So these are your YubiKeys. How many of you are familiar with YubiKeys? Nice. How many of you use YubiKeys? Nice. So this is a YubiKey. This is a YubiKey with a fingerprint sensor. There are YubiKeys without that, without fingerprint sensors. There are YubiKeys which are like really tiny, nano ones. And there are other brands like Google's Titan and many other brands of security keys. These are devices that can actually create asymmetric key pairs and that can store those key pairs. This particular model, for example, can create and store 25 key pairs. Limited memory, but it can do that. Of course, you can also use your smartphone as a roaming authenticator. So smartphones are unique, as in it is both a platform authenticator, also can be used as a roaming authenticator. So the next piece of the puzzle is FIDO. So FIDO stands for Fast Identity Online. So FIDO Alliance is a global organization of security enthusiasts and security-focused companies coming together to kind of get rid of passwords, make the internet a safer place. They are the advocates for Passkeys and public key cryptography-based identity. So again, this entire standard is based on public key cryptography, the digital signature mechanism. So FIDO is the authentication standard that makes Passkey possible, right? And FIDO 2 is the specific standard, the current version, which makes it possible, which is comprising of two other standards. So this standard is nothing but a combination of Web Authentication and client to authenticator protocol. So let's look at them one by one. So Web Authentication is a W3C standard, right? It has been around for a while. How many of you are familiar with it? Yeah, okay. We are Java folks, not in the Java ecosystem. It's more of a JavaScript stuff, but it has been around for a while. It has been used for multi-factor authentication implementations like FIDO multi-factor authentication and these kind of stuff. So Web authentication provides a set of API with which you can talk to authenticators from a JavaScript application. That is what Web Authentication provides. And underneath, Web Authentication uses the browser's credential management API. And in case of mobile phones like Android or iOS, both these platforms have something similar to a credential management API on the platform. It makes use of that. Next is the client to authenticator protocol. Okay, no, I need to go over this first. So web authentication, the architecture is quite simple. We saw what an authenticator is, right? So an authenticator is responsible for saving metadata, some metadata, and private keys. Then we have something called a relaying party, which is a fancy name for your server or whatever service that requires authentication. So basically your backend. So your backend, in this case, stores the public key, username, and whatever other metadata it needs. So a relaying party can be your own web server or a service like Auth0, Amazon, Google, any SSO provider, or any OAuth IDP, identity provider. So they can be the relaying party. And the third piece is the client, which comprises of the browser and the user, right? The user is just there for providing consent or user interaction. So the browser does all the work of talking to the authenticator and sending data to the relaying party, and vice versa, right? So it makes the communication possible. So that's the web authentication architecture. Then we have client to authenticator protocol. So CTAP, short. So CTAP is used for communication with authenticators. So specifically roaming authenticators, not for platform authenticators. So the communication happens over USB, Bluetooth, and NFC. So a browser can talk to platform authenticators using the platform authentication APIs of the platform, like the Windows one or Apple one or whatever. But if it has to talk to roaming authenticators, then it needs CTAP too, because the platforms, they don't provide a mechanism to talk to roaming authenticators. So that's why CTAP comes into the picture. So these are the building blocks of Passkeys. These are the technologies that makes it possible for us to use Passkeys, right? Technically, Passkeys are discoverable passwordless FIDO credentials. Very mouthful, not very easy to market as such. Passkeys was kind of a marketing term from Google, Amazon, Apple, Microsoft, and so on. Kind of caught on. Now it's considered a noun. So any FIDO passwordless credentials are considered passkeys. Again, this is an evolving standard. Things are changing. Things will change a bit more. There is a huge push from these big companies for passkeys. How many of you already tried passkeys in some service? Nice. So a lot of services already supports passkeys, like GitHub supports, Google supports passkeys, Facebook, I think, recently started supporting passkeys, Twitter supports passkeys, a lot of other services, they support passkeys. And a lot of password managers have started supporting passkeys. So there's a huge push for passkeys. Again, for now, this entire thing is in the tech bubble. General population don't care or don't know about these, and probably nobody is going to invest in these unless there is a push to force them to, because general population are not as security minded as tech folks. So we are kind of the beta testers, if I may. So let's go a bit more deeper, right? So passkeys have two variants, actually. So we have something called synced passkeys. So synced passkeys, so in case of synced passkeys, the private key gets synced between devices in a particular ecosystem. So for example, if you're in the Apple ecosystem and if you create a passkey using, let's say, your MacBook, right? So Apple end-to-end encrypts your private key and stores it in the iCloud keychain. So when you log in, when you go and use your iPhone, for example, this private key is already available for the device. So the device automatically downloads this private key from your iCloud keychain and stores it in its own TPM module, or the Apple enclave thing, right? So any device in that particular ecosystem, which is bound by the same user ID, gets the private keys. That's why it is called synced. There is the advantages of this approach is better usability, because you don't have to go and register each device. You only have to register with one device and it's available in all the devices in that particular ecosystem, one-time enrollment. It can be restored in case you lose all your devices. You can still get it from your iCloud keychain in a new device. So when you add a new device to the ecosystem, let's say in the Apple case, if you sign into a new device using the same Apple ID, the private key gets restored, right? So there is automatic backup and restore for sync passkeys. The downside is slightly less secure because, again, your private key gets sent to a cloud. Even though Apple's iCloud keychain is very secure, the private key itself is end-to-end encrypted using your iCloud credentials and everything, still there is the component that it gets sent to a cloud, so theoretically can be breached, right? Even though it would be very difficult to breach it and use it after that, but theoretically possible. So the other type of passkey is called device-bound or hardware-bound passkeys. So the only difference is that with device-bound passkeys, your private key stays on the device. It doesn't get synced anywhere. So it is local to the device. So in case of the YubiKey, it is on the YubiKey. It doesn't go anywhere, right? Which means it comes with the opposite of that, right? So which means not as convenient because you have to register every authenticator device that you use. Like if you have 3 YubiKeys, then you have to register all of them for each service. There is no recovery or backup. So if you lose your YubiKey, the private key is gone. There's no way to recover the private keys. There's no way to back them up because by design, you cannot get private keys out of YubiKey or any security key, right? That's the security promise of that. So there's no backups and recovery, but advantage being it's the most secure option. It is considered the golden standard for security. Like device-bound passkeys are considered golden standard for security. So it's the most secure option because it is something you have. It doesn't go anywhere, right? So for example, I use a YubiKey for all passkey stuff because I'm on Linux and platform authenticators are not supported on Linux. Shame on the browsers. So I'm left with two choices: either use my mobile phone for all synced key stuff. I can still do that. I can still let's say Google's ecosystem also supports like very similar mechanism to Apple's, right? So if I create a sync passkey using my mobile phone on a particular service, and I store it in my Google's password manager, right? The Chrome password manager. Then I can go into any service using Chrome, and that passkey will be available to me. The only difference would be that I would have to take my phone out and do the authentication each time. But it is still possible. So I can still create sync passkeys using a mobile phone, even if I'm on a device that doesn't support platform authenticators. And of course, for I can use YubiKeys for wherever passkeys are supported, I can use YubiKey. But I have to bear in mind the downside that I need to keep it secure. I need to make sure that I register multiple keys, which is suggested best practice even for MFA. If you're using a security key, you need to use multiple as a backup, because if you lose your primary, you can use the backup keys. But in practice, not a big deal. The only downside is I always forget to take my YubiKeys along. So sometimes I'm in somewhere, oh shit, I don't have my YubiKey. So that's an annoying thing. But other than that, it's fine. Right? I survive. So how does the magic happen, right? Yep, 27 minutes. So how does the magic happen? Let's look at the entire flow of passkeys. So there are only 2 flows for passkeys. There is a registration flow and there is a authentication flow. That's it. So the registration flow starts with a client, or you, a person, going to a website, right? Let's say we go to a website, there is a register button, you click on that, then the client-side implementation for that particular website would ask its server or the relaying party for a challenge. A challenge is nothing but a random piece of data, and in most practical use cases, it is going to be a string, unless you really want to use another format. So it's mostly going to be a random base64 string or something like that. So you get the challenge back from your relaying party. Then the client calls the navigator credentials.create method. This is one of the WebAuthn API. There is only 2 WebAuthn APIs. So it calls that method and passes, of course, it passes the challenge to the method with other metadata like the domain where it is being run, the username that you wanted to use, and whatever other metadata that needs to be passed, like the signing algorithms that you want to use, like let's say DDSA or RSA, whatever. You can specify those in the create method. And once the create method is triggered, WebAuthn API again decides based on what kind of authenticator you use to call the platform auth API or CTAP to communicate with the authenticator. So of course, once the authenticator is triggered, the user would have to provide a consent by touching the device, or some sort of consent. You have to provide your presence. One required thing for authenticators is presence. You need to be physically present there. So, and you need to provide consent in some sort of physical action. So once you provide that, the authenticator, right? It's nothing to do with the WebAuthn API or your client implementation or even your OS, right? The authenticator, which are the synced, the platform or the roaming authenticator, creates a new pair of asymmetric public key. And when this new pair of key is created, right? Like when you create a public key pair, you can bind it to certain things, like whatever you want. Like normally you will bind it to a passphrase or something like that. But in this case, it is bound to the domain name and the user ID that you're trying to use. So it is bound to these. And once it is created, in case of synced passkey, the ecosystem, of course, let's say Apple or Google's ecosystem, it syncs that private key into the cloud so that you can use it with other devices. Everything else remains the same. So there's that step is not applicable for device-bound passkeys. So once the keys are generated, then again, the authenticator creates an object called attestation object. And this attestation object will contain it will sign the challenge that it received using the private key, and it will go into the attestation object along with the public key of that combination and unique credential ID and some other metadata, like the certificates used and whatever, the algorithm used, some metadata. It puts all this metadata into the attestation object, and your client-side implementation for that .create call, it will get this attestation object as the result. And once you get that, your client side can pass that back to your server or your relaying party. And the relaying party will verify the challenge because it has the original challenge that it issued. So it will verify the challenge that it received because it has the public key signed challenge. You can verify, and if both challenges match, then you are registered, right? Because it is a valid identification flow. So you are registered in the database. And if you notice here, you're only saving metadata like the username and maybe the credential ID and whatever other metadata you need, and the public key. There is no sensitive information here. So you don't have to worry about encrypting those or salting those or whatever. You don't have to do any of that. It is not sensitive information. So these are stored and registration is complete. So now we can authenticate, right? So authentication flow, very similar to the registration flow with minor differences. Again, you go to the website, you click on login. It will ask the relaying party for a challenge. You get a random challenge. And your client side will call the credentials.get method. So this is the second web authentication method. And again, it will pass the challenge and some metadata to the method. WebAuthn will trigger one of the authentication APIs. And depending on consent, so the user will provide consent, and depending on what kind of authenticator was used, again, the device will surface private keys which matches the domain where it is being triggered and the user ID that you are trying to use. Before this, there is a step that in the UI, right, in the browser UI, it will show you all the credentials available for that domain. Right? So it will just show the usernames. Like if you have 3 usernames registered with that domain, it will show the 3 usernames. You click on one username, and then the authenticator will select the private key for that particular username, and it will sign the challenge using that private key. And of course, for the sync passkey, if it is a new device, there is an additional step of getting the private key from the cloud. That only happens the first time you use a new device on a platform. Otherwise, that step doesn't exist. So it signs the challenge using the private key, again creates an object called assertion object, because earlier you were registering, right? So it is an attestation, you are attesting. Now you are asserting, so it creates an assertion object. Again, it puts the signed challenge in the object along with credential ID and some metadata. Your client side gets this back, and it can send that back to your backend or relaying party. And again, the relaying party now has the challenge that it issued. It got back the signed challenge, and it has the public key of that user already. So it will verify the signed challenge using the public key, and if it matches the original challenge issued, then which means whoever did the consent has the public key, or has the authenticator that has the private key for this public key, which means you can authenticate that person. The identity is verified and the person is authenticated. So that's the entire web authentication flow. And of course, these transports, they use CBOR encoding because it is much more, it's similar to JSON, but non-human readable. It's much more concise because there's a lot of metadata here. So it uses CBOR encryption to pass around the data. So you would have to decode that on the server side. So that's the entire flow. So now that we understand what Passkey is, how does it work, right? Why Passkeys, right? How does this solve the issues that we saw earlier? Of course, Passkeys, by now you should have understood that it is security-wise, it is much more secure than a password, right? Because it uses cryptography. It's much more secure than passwords. It is also much more secure than using a password plus traditional OTP combination like SMS OTP or something like that. I'll come into that, why. But let's first see how it solves the issues that we saw. So we saw all these issues with passwords, right? Let's see how these are solved. So passwords were knowledge-based, right? So which means it is something you know, whereas passkeys are something you have. And in 99% of the use cases, it is a combination of something you have and something you know. So passkeys by nature is multi-factor. Because there is a requirement for passkeys that there should be some sort of user consent. Of course, you can. There is a in the API, when you do the API call, you can disable user verification, but the recommendation is not to do that, so that it is always multi-factor. So when it is enabled, so you always need to provide consent either by a fingerprint or by a small passcode. So if you are using a YubiKey, for example, without a fingerprint sensor, then it would ask you to enter a 4-digit passcode, which you would set up when you register the YubiKey for the first time. So there is always 2 factors involved in most cases. Of course, you can disable that, but regardless. In any case, passkeys are something you have and not something you know, which has its own advantage, which means you cannot be socially engineered unless someone socially engineers you to hand over your device or your YubiKey along with the passkey or your finger, cut your finger and give it to them. That would be the only way to social engineer that. So phishing, right? Passkeys are phishing resistant because it is not going to work on a phishing website, because the authenticator will only surface keys that matches the domain, and a phishing website cannot be the same domain as that you actually registered, right? So when you go to a phishing website and you won't even get any option to do anything. You cannot do anything. You'll go there and you'll be like, okay, what am I? I cannot do anything. So you'll know that it is a phishing website, or you'll think that, okay, something is broken. But regardless, cannot be phished and nothing is sent over. Similarly, it cannot be, you cannot man in the middle passkeys. You cannot sniff passkeys. So it is phishing resistant. And again, because it is something you have, it cannot be remotely breached. If someone has to breach it, they have to be physically present there, have access to your device or the YubiKey or whatever. So it cannot be remotely attacked. And breach resistant, because we are not saving any sensitive information, right? We are not saving passwords, which makes our server less attractive to hackers. Unless you have some other thing like credit card or something, then it is no point breaching your database, because there are no passwords. You may as well distribute the public keys publicly. It doesn't matter, right? And again, because it is cryptographic keys, it is not reusable, because every time you create a passkey, it is a unique key pair that gets generated, so nothing is reused. And shareable with a star. It is not shareable. By spec, passkeys are not shareable, but Apple went ahead and made it shareable. So Apple being Apple. And management, right? Password management part. Passkeys are easier to maintain, especially for synced passkeys. You don't need recovery flows. You don't need to build reset flows. You don't need MFA, because passkeys are by default MFA. So you don't need to build all that. So it reduces the effort on implementation side. It reduces that maintenance effort and all that stuff, because the recovery, backup, all these things, at least for sync passkeys, is moved over to the platform rather than your application. And of course, passkeys are also passkeys have cross-device authentication capabilities, which means even if you are on the Apple ecosystem, if you want, you can use an Android phone for that passkey lifecycle. Similarly, on a Android ecosystem, you can use iOS if you want. How the cross-device authentication works is quite interesting, because in cross-device authentication, you'll be using a mobile phone, right? And that is how I am using sync passkeys, for example. So I use the mobile phone always for the authentication and stuff. So it is my authenticator. But in that case, the implementation, the web authentication and the FIDO implementation ensures that my mobile device is in close proximity to whatever device I'm using for the sign-in. So if I'm using my mobile with this laptop, so for this to work, both devices should have Bluetooth, and Bluetooth should be enabled. So what it does is it looks for the Bluetooth signal emitted, the low energy signal emitted from this device. So it makes sure the signal is available. And if the signal is available, then you can approximately say the device is within like 100 meters, right? So there is some proximity. So it ensures that, so that there is no way of remote breaching. So if you plot passkeys security and usability, right, against, let's say, passwords. So of course, passwords are the least secure. Just using a password is the least secure form of identity, but it is also very convenient, right? It's easy. There's a lot of things involved. Everyone knows how to use a password. The next would be slightly more secure, would be using password with some sort of conditional MFA, like conditional OTP or something like that. It is slightly less convenient, but slightly more secure. And even more secure would be using password plus a mandatory second factor authentication, right? Again, slightly less convenient, but more security. Even better would be to use some sort of social login, or to social login, like using Google SSO, or I don't know, Facebook or Twitter, whatever. Because these companies, at least in theory, are more secure. They have a more secure way of storing your credentials and stuff. And if you're logged in with Google, you can, at least the expectation is that it would be more secure than your own implementation. So you can use that for identity. Of course, it is like great usability there, because you just click on, hey, log in with Google, done. You don't have to log in each time and all those things. It is also more secure because it uses two flows, and the assumption is that they store everything very securely. Even more secure would be sync passkeys. Also, sync passkeys are very good usability, because not a lot of things involved. Unlike using a YubiKey or something, your sync passkey is going to be on the device, so mostly you are just going to put your fingerprint on the, so let's say, Touch ID or Face ID, or Face on Face ID or whatever, right? Similarly secure, but slightly less convenient, would be password plus any sort of FIDO MFA. FIDO MFA is more secure than traditional OTP-based MFA, because FIDO MFA is again cryptographic based, so it is more secure. So it is as secure as sync passkeys, but slightly less convenient, because there is 2 steps involved. And of course, the most secure option would be device-bound passkeys, but again, it is less convenient, because you have to use something, an external device, you have to carry it around, all that things associated. Of course, that doesn't mean there are no challenges. There are some challenges, because it is an evolving standard. Things are moving. So OS and browser support is one of the major issues. We all know, right? When when a W3C standard is involved, there is always fun issues with interoperability and the browser support, and not uneven implementations. And you can already see this, like Chrome and Firefox have different UX for this, for example. So you will anything that is W3C, you will always see these kind of discrepancies, which is the case here as well. And again, operating system support, for example, on Linux, there is no support for platform authenticators, because the browsers don't want to implement that. They all use Linux for everything. They make money from Linux, but they don't want to support it for users. It's great. Sorry, I'm ranting. Cloud vendor reliance. So there is a privacy concern over handing over your identity to like Google or Apple or Microsoft, because a lot of people don't trust these companies. So it is a valid concern handing over your all your credentials to them. Of course, most of us probably already do this with Google's password manager or the Apple iCloud. So similar thing, but more reliance on them. We expect them to save these keys securely and all these things, right? Passkeys are not great with enterprise use cases. For example, if your enterprise doesn't allow Google or iCloud, most enterprises don't, right? They block certain services. So if your enterprise doesn't allow these services, then you cannot use sync passkeys. You might be able to use sync passkeys with the password manager because most password managers also support sync passkeys these days. But if your company doesn't support those password managers, then again, you won't be able to use that. You might still be able to use device-bound passkeys, and probably for enterprises, that would be the preferred way, because enterprises are already familiar with using YubiKeys for MFAs and stuff, so it's not a leap for them to use device-bound passkeys, right? And again, if they have specific use cases regarding rotation or whatever, that could be a bit tricky. And finally, reset and recovery. I mentioned that with passkeys, you don't have to do any of that, right? Which is true for sync passkeys. But for device-bound passkeys, there is no built-in mechanism for recovery or backup. So it is up to the implementer to provide some sort of recovery, and you don't need reset, but you need some sort of recovery. For example, the ideal approach would be to when you map your user schema, to make credentials one-to-many. So one user can have multiple credentials. That would be ideal, because then your user can register multiple devices, like multiple YubiKeys, as backup. So that would be ideal. But regardless, you would have to provide some sort of recovery in case they lose their keys, if you are supporting device-bound passkeys. So, web authentication with Java. Though web authentication is a client-side thing, JavaScript framework, JavaScript API. The clients, the most of passkeys are client-side thing, but you also need a server-side component, because you have to decide certain things on the server side. For example, you have to provide challenges from the server side. You can decide the configuration on the server side and pass it on to your client end. And of course, we like to do all secure things on the server side rather than the client side, right? So for that, for Java, we have two libraries. We have WebAuthn J, which is 100% FIDO2 compliant, supports all attestation formats, all validation formats. And you can implement relaying parties with WebAuthn J. You can implement multi-factor authentication with it. You can implement passkeys with it. It is used by Keycloak as the passkey web multi-factor authentication support. And it has very good Spring security integration. So it gels very well with Spring security. And you can use it in the same way that you currently use Spring security's filter chain configurations. It is also Kotlin friendly. And then we have Java WebAuthn Server, which is from Yubico. And ironically, it is not 100% FIDO2 compliant, even though they are one of the FIDO Alliance members. But it supports most attestation formats. You can implement, again, passkeys with it and relaying party with it. But some attestation format might not be supported. So for very advanced use cases, might not be a good choice. So I would always recommend WebAuthn J, because it has great Spring integration and everything, and easier to work with. So let's see passkeys in action. So I'll do one demo using an IDP, because I work for Okta. And I will do another. I also implement a non-IDP solution, so I'll also show that. This is almost like cheating, because I'm actually not implementing the passkeys thing myself. I'm just using Auth0, and it already has passkey support, so it basically does it for me. So I'm basically going to do a OIDC implementation. Okay, where is my... I lost my mouse. Okay, it's here. So I'm going to create a Spring Boot app. Okay, so I'm using start.spring.io. Very simple app. It has two dependencies: the web dependency, web MVC dependency, and the Okta starter, which auto configures OIDC and OAuth2 for the application, so you don't have to do that yourself. So I'm going to create the application with that. Done. Very basic applications, nothing much to see there. So now I need to configure an OIDC application. For that, I can create an OIDC application on Auth0 using the Auth0 CLI. So again, I'm configuring callbacks for that for the application that I created and logo URLs for that. So once I create this, I have a OIDC application on Auth0 side. I have my client secret and client ID here, which I need to configure on the application. So let's go into OIDC login and let me create application properties. So it is recommended to, so when you are dealing with any sensitive information in a Spring Boot application, it is recommended to create application properties on the root of the your application and add it to git ignore, because Spring will automatically read this application property and override the values from that. But since it is a separate thing on your root, it is almost like .n files that you use in other ecosystems. Of course, you can do .n on Spring, but you need an additional dependency, some gymnastics around. But this is a more native way in Spring ecosystem. So let me copy my client. And my client secret. It's a throwaway application, so I don't mind showing the secrets. Okay, so I have my application properties configured. So this will configure, this will enable OIDC and OAuth2 on the application. I don't have to do any code per se because I use the Okta starter, which auto configures OAuth2 and OIDC. So I just need to provide this and it will work like normal Spring magic. Of course, I need a controller, so I'm going to create, I'll do it here. So I need a controller, again, a very basic controller with a mapping for root, which returns your username. That's it. So just returns your username. That's it, very simple stuff. Okay, I need to create the file first. Yeah.
You just need to be in the...
Sorry?
You're not in the right directory.
Oh, yeah, thanks. I always do that. Yeah. Let me make sure I created the application properties at least. Yeah, I did that. So let me start this up. So I'm going to show the cross-device thing, how it works. And if I have time, I have 4 minutes left. So if possible, I'll also show the YubiKey stuff. Come on. Faster. Spring, you're supposed to be fast. Supposed to be under 1 second or something. Really? Huh, maybe. I didn't do any sacrifice to the demo gods today, so. Why? Huh. Yeah. As usual, just need to turn off and turn on again, right? So since the Okta starter auto-configures all URLs to be secured, so when I try to log in the root URL, it automatically takes me to the sign-in screen. So here I will sign up. You can see that already shows you the continue with Passkey stuff. Of course, you need to enable this on your Auth0 tenant, but that's a one-time thing. You sign up to the Auth0, you get a tenant, and you enable Passkeys there one time. Then you get Passkeys on all your application. Okay, I'm going to put something here. So it's going to ask me to create a passkey. So I'm going to, yeah. So this is the normal UI. And if you already have your devices registered in the ecosystem, you're going to see like my mobile phones here. So I can use one of that for passkey. So I'm going to use my registered mobile, or you can use another security key, or you can register a new phone at this stage, or you can use your platform. thing. You don't actually have to select these. If you're using a key, you don't have to select anything. You just touch the key. It knows that you touched the key. It will use that. Or you touch your Touch ID thing. It will know. Only for the phone you need to select if you want to use the phone. So I will get a notification. Hard to show. I didn't touch. Oops. I'm going to try again. Something happened. I think I lost the notification. It just goes away. See, that's what I said about that being evolutionary state. I'm going to try one more time, or I'm going to move on to. I'm getting the notification, but when I touch it, it just goes away. Okay, I don't want to restart this and everything. I'm just going to touch my UB key. So I touched my UB key, and it is going to use that instead. The internet is a bit slow, huh? So yes, signed in and all those things. I'm going to try the other one. I have 1 minute left, so no point. So I'll just show you this. So that's using an IDP, but you can also do it yourself using WebAuthn with Spring Security. So I implemented something. So if you're interested, please go to this repo, take a look. Again, very simple Spring Boot application with the same command. I added a security config file, and I configured the filter chain using WebAuthn 4j. That's it. So and then I implemented a controller for the sign-up method where I would get my passkey thing, and I can do validation there. I can store it in memory or to a database or whatever. So if you're interested, check it out. And how does it differ from MFA? Very similar in terms of implementation because both use the same standards. The difference being passkeys have two variants. MFA doesn't have a synced variant. Passkeys are first factor. MFA, technically you can use it as first factor, but nobody does that. It's always used as a second factor. Passkeys are discoverable credentials, which means they are client credentials. They are stored on the client side. Whereas MFA is server-side credentials or non-discoverable, they are stored server-side. So when you create passkeys on a UB key, it is on that device. But if you use the same UB key for MFA, the private keys are not here. The private keys are actually sent to the relaying party in a very complicated manner, and they store it. That's why when you use UB keys for MFA, you don't get any issue with running out of memory. You will never see that. But if you use UB keys with passkeys, once you create 25 passkeys, and then if you try one more, then it will say no more space available. You would have to go into your browser settings and delete some of the keys if you want to continue. So that's a restriction of the keys. I'm pretty sure now that this is being pushed, Ubico will come out with a key with more memory. Memory is so small these days. So, and of course, yeah, the enrollment thing. Device-bound passkey again is very similar to this MFA, except for the discoverable credential part. And if you want to learn more, some resources you can check out. And yeah, if you want to try Auth0, please feel free to do so. Obligatory advertisement. And thank you. So I hope it was worth your time.